All right, y'all. So we got a little bit of chapter 6 to finish up, and uh, essentially, this reaction is one that is in organic chemistry too, but looking at the different steps will allow us to practice things that we've learned in chapter 6 and even before chapter 6. So um, this is a reaction, and I'm going to draw part of the mechanistic steps. And what I want you guys to do is take time to pause the video and try to predict um, what the intermediates of those steps actually look like. So when these two things are mixed together, the first thing that's going to happen is this oxygen is going to add its electrons there, and then that arrow indicates those electrons moving up. So what would the intermediate here look like? Take a minute to pause the video and try to draw that intermediate. Boop. You've paused it, you're doing it. All right, you've unpaused. So that oxygen is connecting to that carbon. It's used up one of its lone pairs to make that bond, which now gives it a positive charge. Also, this oxygen here was double bonded, now it's single bonded, which means it has 3 lone pairs and a negative charge. What happens in the next step? So in the next step, these electrons are actually going to come back down and kick out the Cl. So what does that make? So again, pause the video, boop. Now you're predicting what that makes. We have to be able to understand what the flow of electrons is indicating for how molecules are changing. So practicing this stuff is really important. So that's going to make this and Cl minus. So the next question is, how does this become the product? So you should be able to draw a mechanistic step for how that happens. So again, pause the video, draw the mechanism of how that becomes that. These mechanisms are going to be really helpful for us to understand why and how the reactions work the way they do. So we have to be able to account for the electron movements. So what happens? Well, H is now attached to Cl, so that's one thing. How many lone pairs are over here? Cl has 3 lone pairs there. Here it has 4 lone pairs, so it must have used one of those lone pairs to make a new bond to that hydrogen. What about the oxygen? 2 lone pairs there, only 1 lone pair there. Where does it get the other one from? It must get it from the oxygen-hydrogen bond. So what about all the things that we've learned in chapter 6? We learned about arrow pushing. We've learned about reaction coordinate diagrams, and that's kind of where this falls. We're on page 10, the bottom of page 10 from the notes. And essentially, what I'm going to tell you about this reaction is that this is the slow step. So that's the slow step, and what you should be able to do from that is generate a reaction coordinate diagram for this reaction. And the other thing that I'll tell you is that it's an exothermic reaction. It's exothermic. So with those two pieces of information, you should be able to generate some type of reaction coordinate diagram that makes sense. So pause the video, practice, and then we will see if we got the same thing. Whoop. All right, cool. You did it. Great. So reaction coordinate diagram, what does that look like? It's got the reaction on this axis. It's got delta H, or energy, on this axis. So what happened? What do the things tell us? Well, exothermic means that if the starting material is over here, the product is lower in energy. So we'll put the products down here. What about however many hills we're going to have? The hills correlate to the number of steps in the reaction mechanism. So this is one step, this is a second step, this is a third step. So there have to be 3 hills in this reaction. What does this tell us? That this is the slow step. The slow step means that that is the rate determining step. And what does that mean for the activation energy? That means that that is the highest activation energy step. So as far as the hills that we have to go over, the highest one is going to be that first one. And then we have, these would be the intermediates 1. That would correlate to this thing, intermediate 1. After another step, we're going to see intermediate 2. So this is going to be intermediate 2. And then the final step gets us to the product. So this is what those steps look like. Another thing you could practice, we're not going to do it in the video, would be to draw the transition states. This would be transition state 1, transition state 2, transition state 3. You're definitely going to have to be doing that stuff on exams, etc. So putting that on here as well. Practicing that would be a good thing to do. All right, hopefully all that made sense. We're practicing those skills, and yeah, thanks for watching.